So today we are starting with a new chapter, that is services and building. In this particular chapter, you have to learn about different services like lighting is there, ventilation is there, acoustic is there. Okay. There are other services like doors, windows, and firefighting provisions, etc. So we'll be discussing each of these things one by one. So today we'll talk about lighting. Okay. Basically, what is lightning? What is light? Simply, it is we know very well that from the very earlier classes, we are very well aware with the spectrum, the distribution of the different rays with their wavelength, right? So out of that spectrum, the light we call it to the particular part of the wavelength that is in the range of 400 to 700 nanometer. That is only visible to the human eyes. Okay, so that's why we are very used to it, and that's why we call it as light. Okay, so that is the technical definition, that the wavelength for light ranges from 400 nanometer to 700 nanometer. Okay, so that is the part of the visible spectrum. Beyond it, it will be what? Ultraviolet rays. Okay, and below it, it will be what? Infrared. Okay, so considering that aspect, there are other uses of those rays, means those wavelength also. Okay, especially if we talk about the uh, cooking something in the oven, microwave, or if we talk about the radiation for the mobile network. Okay, so it all depends on the wavelength and all the other things, but we are particularly concerned about this visible part of the light. So that is in between 400 to 700 nanometers. Okay, so that is our concern, that is our matter of study. Fine. So how to measure it? If someone asks you that what is the unit of measuring it, first of all, if we talk about the procedure of measuring the light, so it is as simple that we use electronic equipment over there, which is very well equipped with the sensors. That sensor actually senses the amount of illumination inside a room, and then it will give you some reading in terms of different units. Okay, it may be in terms of lux, in terms of lumens. Okay, generally it is in terms of luxes. Okay, so depending on that, we'll be getting some mathematical measures for the lighting. Okay, so that is how we do measure the lighting basically. Indices of lighting, if I talk about, there are numerous or multiple indices. So light can be measured subjectively based on the brightness. Seen subjectively means by sensing it. Seen by the human eyes. The units include the candles, lumens, foot candles, and lux. So these are the very basic and popular units. A source of light has a luminosity of one candle if its output appears to match that of a standard candle. Okay, that means uh, standard candle, what it can provide us, that if that much amount of lightning is there, that means it is going to be what in terms of this candle units. Okay, so a source of light has a luminosity of one candle of its output appear to match the standard candle, right? Flux, that is the luminous flux. Okay, so it is what? The originating from the Latin word fluxes. So that is again another unit, that is the luminous flux over there, and meaning the flow. What is the meaning of flux? That is flow. So like we are measuring the electricity. Okay, so in the same way we are measuring the light here also. So flux is the amount of energy a light emits per second, which is something like flowing over there, and we are measuring it. It can be like a fluid also. Okay, so in this sense you can also measure the light. So it's measured in lumens. Whenever we talk about the lightning fluxes, so these are measured in lumens. So when it comes to the lightning, you need to consider the watts, that is the energy unit, versus the lumens over there. So there is a basic confusion for the student that whether to consider the watts or the lumens. So the very popular is the lumens, because watts we basically use for the energy, and here we are talking about the lightning, that is the visible portion of the spectrum. Okay, so electricity consumption versus the light output, if you compare, so lumens are weighted for the human perception, whereas the watts are not. That means lumens means how we can sense the light, that is the lumens. Whereas if we talk about the watts, that means what we can mathematically measure, that is watts. So energy we can measure mathematically, So that is in terms of watts directly. Whereas if we talk about lumens, that means it is something which is required to be sensed by us, okay, or it requires special sensor to convert it into mathematical unit, right? So these are different units. So if we talk about the lumens particularly, it is the SI unit of the luminous flux. What you have studied here, luminous flux. Flux means what? Something which is flowing. So a light is also considered to be flowing all the time whenever you are studying, okay? Because we know the particle theory and other things, photon and the what you have studied in your earlier classes. So these are all things going to make it as a fluid like substance over there to the lightning. Okay, so this is a unit of the light flow. So that is lumens. Okay, if you talk about watt, that is the electrical powers unit. Okay, so basically we use lumen, not the watt here. If we talk about the other different indices, that means the it is, see, here we have discussed in terms of flow of the light, whereas here we are talking about the intensity of light. Intensity means it depends only on the source. That means larger the source is, more will be the intensity. Okay, like if you are talking about a bulb, okay, so you can compare it in this way. So the quantity of the visible light that is emitted in unit time per unit solid angle. Okay, so that is the quantity of the visible light, how much it is emitting, that is actually the intensity of the light. Here the solid angle means what? The 2 pi, that is 360 degree all round, uh, all way round toward the your source. If you are talking about a bulb, then 360 degree to that bulb axis. Okay, so intensity of light we can measure. It is the quantity of the visible light that is emitted in unit time per unit solid angle. That means for the 360 degree. It can also be measured, if you are talking about the intensity, that can also be relevantly measured with the candela. Okay, so the SI unit, I hope you have gone through this word candela in your basic physics, in basic thermodynamics. Okay, आरबीएससी में उसको क्या बोलते हैं हम, उष्मीय गति, उसमें आपने पढ़ा होगा. ओके, so the SI base of the unit of the luminous intensity, it is unit of the luminous intensity of a light source in a definitive direction. That means whether you are what is your angle of vision from where you are looking at. Okay, so that is the candela unit. So 1 lumen equals to 1 candela into the SI unit of the solid angle. ठीक है, समझ में आ रहा है कि नहीं, क्या पढ़ा इतना कि मैं ऐसे ही बोले जा रहा हूँ.
आ रहा है.
Whereas illuminance, if we talk about the amount of the luminous flux per unit area, we are considering. So that is where we are talking about the intensity of light, we are considering it on uh, the angle of 360 degree. Whereas if I talk about the illuminance, illuminance means what? It is distributed on per unit area. So depending on the type of measurement, that whether we are talking it in reference with the sensors, that electromagnetic sensors, whether it can be, or the natural sensors which we are being assigned with, like our eyes. Okay, so if we are sensing it, that means it is somewhere in the flux. If it is distributed in terms of intensity on the 360 around the source, that means we are measuring it in terms of candela or intensity of light. And if it is, we are measuring it like it is distributed on some area, on some unit area, that is, let's say for a feet square, for a meter square, that means it is illuminance. Okay, now if we talk about illuminance, so illuminance is that particular terminology. When we consider the light on the unit area, that means it is called as illuminance. Now that is not unit. Unit is what? Lux and the foot candle. Okay, so if you are considering the light on a distributed area, that means the unit will become what? Lux. Okay, so lux is a standardized unit. It is written as LX. Okay, standardized unit of measurement of the light intensity. So the SI unit of the illuminance and the luminous emittance, that is 1 lux is equal to the 1 lumen per square meter. Okay, 1 lux means what? It's equal to 1 lumen. That means this much amount of intensity over 1 square meter. That means 1 lumen intensity over 1 square meter, that is going to give us a value of 1 lux. Whereas if we talk about foot candle, that is a non SI unit. Comparatively, you can see here there is a feet square. That means what? It is an MK, CGS or FPS. This system we are following here. As it is in feet square, that means we are using foot poundal second. Okay, have you gone through this whole system of measurement, different units, MK, CGS, FPS?
Yes, sir.
Okay. What is MKS?
meter kilogram
Second. Okay. CGS is centimeter gram second. Then foot pound al second FPS. Okay. So out of this all, this foot candle is basically a FPS system. Okay. So that is a brief discussion about the lightning or the measure of the different indices of the lightning. Luminance is the intensity of light from a surface per unit area in a given direction. That means candela per meter square, or you can write it as 1 candela per meter square. Okay. It is also somewhere written as 1 nit. Okay. So nit is again this 1 candela per meter square is nothing but the nit. Okay. इसी को अलग से नाम दिया होगा. जनरली इतना नहीं पूछते हैं. इतना अगर आप पढ़ लेते हैं तो इट इज इनफ. दैट इज फॉर एक्स्ट्रा नॉलेज. ओके. So, comparatively, if I make a broad statement here, so for an easier understanding, depending on the type of measurement, what I told you that depending on that how we are measuring the light, depending on that your unit will change. Okay, whether the light from a lamp is measured in lumens, okay, it is in that way, or the light that falls on the surface is expressed as lux, that is you are measuring it on a surface, okay, or the human eye that sees this visually in terms of the brightness, luminance, that means in terms of sensing it. Okay, so that is measured in candelas and etc. So in considering all these things, means these are the possible ways in which you can measure the lightning. Okay, is that clear? How to measure the lightning? What are the units?
yes sir.
Now, from a building planning point of view, why this lightning is important for us? Why we are very much interested in talking about the lightning condition? So you all know that lightning is a must for we can say what for day-to-day work and for any special task, for any detailed work over there, for the working in the industries, for the working in the factories. Okay, and means for any building, irrespective of their occupancy or type of nature of it, light is actually the must of must to be there. Okay, and the light actually comes along with the what we can say it like along with the conditions of health also. So if poor lighting, you are working in a poor lighting, that means you are going to harm your eyes. So it is related with the uh, what we can say with our health also. Okay, so in that aspect, the lighting is very much important, right? So various exercises require various degree of light, depends on the details of the task. That means how fine task we are going to perform that require much and much lighting over there. A process control room, that means like working in any industry or something like that, will be lightened at an illuminance of 300 lux. That is the basic requirement. A corridor or a walkway may only require 50 luxes over there. Okay, so you can relate it that what is the measurement of the lux here. I told you that if you want to convert it, that means it is what 1 lux means, that is the luminance we are measuring per meter square. Okay. So while studying an engineering drawing, it may require 750 lux over there. So in this way, you can classify different units, right? Studies have shown that giving the laborers in an open arrangement of workplace, that means providing a good lighting condition over there, will actually increase their performance, okay, and will decline the experience of their pressure. That means if you are working, if this is that point which I actually want to relate with the health. Okay, so actually, if you are working a good lighting condition, then there will be less pressure or less stress will be there, right? So it declines the experience of pressure if there are good lighting conditions over there. Whereas the directional sources of light can bounce off on the reflective surfaces. We know very well that if a light is falling onto any particular object or a particular what we can call it as a let's say for a window glass or for any reflective screen over there, so it is going to reflect again. Okay, so using the blinds, the what we can call that the glare filters. Okay, these are all the accessories which are very important to exclude these reflective lights over there. So it is from the principal source and then again from the reflection. So these are the inputs of the lightning. Okay, so the one image on the right side, top right side, is nothing but the, it's showing what, it's showing such a screens. Okay, so different kinds of screen we can use to control the uh, lightning inside a room. So in this way, I hope you have seen this kind of screens in the windows. Similarly, you may have different kinds of filters over there. So if you use the glass filter, so before and after you can see that how much glare is there before applying the filter, whereas after applying the filter, it is actually the optimum light condition which is required over there. Okay, so the glare will also affect the human health, because more the lightning, okay, it will be very difficult to work over there. Less the lightning, it will be again difficult to work over there. But lightning should be there in the optimum quantity. Okay, so considering that aspect, you can compare this figure. Right. So these are the basic principles regarding to lightning. There are some more principles, that adequate artificial and where possible natural lightning. That means we can have the sources of lightning as artificial as well as natural. But we should use natural lightning, and we must be dependent on natural lightning as and when it is available to us. But when it becomes very difficult to obtain or to save the natural light, to procure the natural light over there, then we are opting for the artificial light. Artificial lightning will going to serve you in the absence of natural light, but it will cost you again. Okay, so it should be our motive whenever we are designing for a building, that it should be naturally lighted, and it must have artificial lights, so that in case of accidents, or in case of, let's say, special cases where natural light is not available, or it has been obstructed due to any reason, due to the cloudy weather, or due to the different weather conditions over there for different seasons, so at that time we can use the artificial light as an alternative. Okay, so in this way you can study this kind of sources over there. So lightning in the stair area especially required when we are talking about the building. So there are different utility areas. Study room require a good amount of lightning. Kitchen, if we talk about it, requires a good amount of lightning. Okay. So in this way, the stair is there is a study which is showing that stair is one most important area in the building that requires proper lighting. Otherwise, there are chances of accidents over there. Okay. So it shows that uh, one study relating to the stairway falls, that means any accident from the stairway, if a person is falling from the stairway. Okay, so regarding that, there was one study, and considering the lightning condition specifically, so it showed that when the light levels are reduced from 86 lux to 22 lux, okay, if you are reducing the lightning level, then what happens, the accident rates will increase. That means it will reach somewhere 11% to 22% respectively, right? So if you are reducing the lightning, that means the cases of accidents are increasing, and that is very obvious for all of us, as we can understand it with the human nature also. Okay, so if there is less lighting, or there is, let's say, dark room is there, then there are more chances of accident. We can understand it, right? So in this way, you have to think about it whenever you are planning a building. So achieving a visual comfort in a building is usually a combination of both the natural daylight, as I told you, that you have to be dependent on the natural lighting, but as and when required, the artificial lighting should be also be available over there. Now, for artificial lighting, again, if you want to make a green home, then you can make this artificial lighting arrangement with the help of green energy. That means the solar panel you can use the wind turbines, you can use the biogas models. Okay, so in that way, you can produce the electricity also. So design should attempt to include a good amount of natural daylight without risking the overheating over there. That means it should not be compromised with the conditions of the weather. That suppose if you are working in a hot, dry climate, and for the lighting purpose, you have provided a big size of windows over there. So it should not be like that. Otherwise, what will happen? From that window, the radiation of the sun will enter inside the building, and it will again increase the temperature. So no doubt there will be proper lighting, but the conditions are such that you will not be able to live there for a what we can say, that for comfortable living condition, it would not be considered good. Okay, so you should not compromise the lighting with the radiations inside there. Okay, so temperature and lighting should be studied very carefully. So natural way, what is the natural way that we can save energy in place of using artificial lighting, which represent a major component of energy consumption in the building. So that is about the different sources, different units what we have studied. Okay. Something more is there that daylight enters a building through skylight windows, so it is very important for you. But the windows can also transmit heat, so we have to be careful about it. Okay, sounds and air are also possibly coming from the window side, so you should also consider these aspects also. Okay, so it is therefore important to consider the natural lighting along with all the other environmental variables. Okay, so now I'm giving you some images so that you can relate it how a window or skylight or different facilities are going to provide us natural light. Okay, we can see here with the help of a window there are some screenings are placed over there so that we can control the amount of heat coming inside the building, right? Again, you can see in the light shelves, these are called as light shelves. That means what? You are taking the reflective sun, not the direct sun over there. Okay, so what is the radiation which are reflecting? You are using that indirectly, and I told you that reflective light is going to provide us the most beautiful light over there. Okay, because it is called as what? Dispersed light. Okay, so this dispersed light will be very helpful while you are studying or while you are reading something. Okay, so in that case the diffuse light will be very much required, and it is considered good because it is glare free light. Okay, so another way is to provide the skylight in this fashion. So you can provide in the, now tell me in which direction you are going to provide these windows, as you have studied about the orientation of the building. So now tell me in which direction you are going to face this opening: east, west, north, or south? Yes,
Sir, east.
east. Anyone else? In northern hemisphere, I told you which is the best suited direction for the lightning purpose. And when I am saying lightning, that means not the direct lightning, which introduce heats also, but it means with the indirect lightning, with the diffuse lightning. Now, considering that aspect, now explain me in which direction you are going to provide the openings of the skylights. This windows should face to what direction? That is my question to you.
The north.
North. Good. Why?
सर बिकॉज इन ईस्ट डायरेक्शन मतलब ईस्ट में तो वो सन का सन मतलब राइज करता है सर।
Mm-hmm.
और सर डिफ्यूज लाइट तो मतलब फिर नॉर्थ में अगर इसको प्रोवाइड करें तो वो सही रहेगा, मतलब
Very
एक
good.
डायरेक्ट डायरेक्ट कांटेक्ट में नहीं रहेगा जो
Direct
इस
contact.
डायरेक्शन में।
Okay. See, you can compare it with the relevant images. That suppose if you are introducing lighting inside the building with the help of this kind of skylight windows over there. Okay. So in that case, what will happen? The low elevation altitude sun will enter into the building directly. Yes or no? Or even the higher altitude sun will enter directly. At this position, the higher and lower altitude sun both will enter into the building directly. Agreeing or not?
यस सर।
So providing these windows, this kind of openings in the south direction will introduce direct heat plus illuminance. That means the glare. Okay, so the glare we have to avoid always, but we require diffuse lighting over there. So most of the time, the diffuse lighting in the northern hemisphere, you will be getting it from the north direction. Okay, so it is as simple. You have, because you want to entertain the diffuse lighting over there. That's why the opening of this kind of facility should be in the northern direction. Now that can be a best place for the study room. What do you think? Yes or no? Is that place can be a good study room?
यस सर।
Obviously, because it is provided with a plenty of lighting over there. Okay, plenty and good amount of lighting is there. So this kind of light shelves can also be used. This requires some additional provision of the glasses over there so that it can reflect the higher altitude sun. So we can use this for the uh, let's say for the day to evening time of sun. We can also introduce it. But all we have to consider is that what the heat should not be increased there. Okay. So obviously, if you are using a diffuse light, that means reflective light. If you are going to use, that means it will be not that much radiative. You can compare it. Okay. Other way is the windows you can provide with the proper screening arrangement if required. If I talk about the different factors of lightning, that what factors which affect the lightning condition, so it will be what? It is very easy for you. So as we are talking about the daylight, that means the natural light. If you are talking about, that means it is solely depend on the conditions of what weather, right? So if the weather is cloudy, that means the lightning condition will be somewhere disturbed. Okay, so the light will not be in that much amount which we required. Okay, so the amount of the daylight available is actually decided with the help of the cloudy weathers and these things. Okay, so any obstructions or the reflectance we can say. So if there is any what we can call it as the some of the reflectance like in this window, they are providing purposely. But if there is any other kind of reflectance is there due to any facility of outside of your house, let's say any hoarding is there, let's say any banner is there. Okay, so considering that, that can be an obstruction also, and that can be a reflector also. So we have to consider this aspect also because it is going to affect the daylight. So internal reflectance of the room finishes, like the color what you are going to choose, the color of the color or the floor finish particularly. Okay, so that is going to affect your daylight. Location, shape and size of the window. For the entrance, more big size of the window, more will be the lighting over there. Okay, and depth of the plan of the room, that means this particular, you can see in this image particularly that how much larger is the size of your room. So depending on that, the lighting will be affected over there. So if suppose this room is too large and you are sitting somewhere in the corner, then it may be possible that good amount of lighting is available to the window portion but not to the other end. Okay, so depending on that, the dimensions we have also to be to consider here. Okay, now, obstructions can be in the form of trees, like you can compare it. Okay, cloudy weather is very disturbing sometimes. Okay, so in this way, there are multiple factors which affect the daylight. So in present day, what the engineers and the architects are doing, they are working on the software to assess the lighting condition inside a building. There is one software called the Radiance. Is a suit means a software which is consisting of the tools for performing lightning simulation. Simulation is what? What do you understand by simulation?
सर प्रैक्टिकल में मतलब उनको देखने से पहले मतलब एक अंदाजा.
Yes, good. Simulation means a visualized study, that in what sense it will look like practically. Okay, so if you are talking, it can be like a structural simulation. That means you are going to measure deflection of a beam. It can be like a load simulation, that what amount of load will be there in the structure. Similarly, some softwares are available like Radiance, which are going to provide you lighting simulation. That is in which corner of the building how much light will be there for a particular sun part diagram or a particular position of the building, right? So it includes a renderer as well as the many other tools for measuring the simulated light levels. It allows an architect to quickly evaluate the benefit of a proposed design. That means in which corner, which facility should be provided, that you can decide. So basically what happens, if you are planning for such a software or working in such a software, that means you have to decide first of all what the shape of your building. I told you in the last class that if we are going to provide a public building, then this public building, to incorporate more lighting over there, to incorporate better ventilation condition, this should be provided in a simplified alphabetical shape. That is, whether in terms of the C shape, whether in terms of U shape. Okay, so I told you that factor, right? So similarly, you have to decide the shape first of all before actually implementing the planning over there. You must decide the shape, that whether it's a L shape building, whether it's a C shape building. Now, after deciding the shape, you will you will conduct the lightning simulation. Okay, and then you will check that at which corner which facilities can be provided from the lighting point of view. Okay, so in this way, these studies are going to help you. Is it clear?
Yes, sir.
Okay. So in some instances, the material, the last factor I'm going to discuss, that is about the material and the paints. Okay, the color what we are going to use inside the building. You can compare these two images, one on the left side of the screen, one on the right side of the screen. You can, which one you can see in a brighter side? Which one is more brighter? Left
Sir,
one or right
green.
one? Green one. Okay. See, that is the impact of color. Due to the light colors, it will always be what? It will be like very well bright room will be there. Whereas in case of dark room with the dark paints, it will be like what? Somewhere the lightning will not be as much active as in that case. It may be possible that in both the cases the amount of lightning coming is same, but the observation, the these what we can call it as the amount of lightning what we can observe from our eyes, that will be affected, right? So in that way the color will play its role in the lightning conditions also. Okay, so you have to choose the color very carefully whenever you are planning for a room in a particular direction. That means your color should be chosen very carefully. Let's take an example. Suppose if you are planning a mini theater inside your house, then there should be very less lighting over there. Okay, so you can use dark color there. Whereas if you are planning for a study room, for a kitchen where plenty of light is required, so in that case you can provide these light colors. So that is the role of dark color and the light colors over there. Okay, other way is the particular this floor finish. Okay, so this floor finish can be in a polished concrete like way. Okay, so it can again reflect the light falling onto it. Suppose this light is falling onto it and it is again reflected back to the other walls of the rooms. Okay, or to the floor, oh sorry, or to the roof area. Okay, so this floor is reflective, whereas you can see here this floor is not that much reflective. So it depends on all these aspects that whether your room will be bright or dark. Okay, is it clear?
Yes, sir.
So that is all about lightning from my side. Is there any doubt, any problem? You can ask me.